So welcome to Electronics XLI, and you are watching Signal System lecture series. And today the topic of discussion is the linear time invariant versus linear time variant systems. So what is linear time invariant system? So a system that obeys the linearity as well as the time invariant property is known as a linear time invariant system. And a system, if it obeys the linearity and the time variant property of this discrete time system, then it is the this LTV system, is the linear time variant system. Okay, so let us see in details. So as I have told you that a system is said to be linear time invariant, that is LTI system, which satisfies the linearity and time invariant property. Okay, so a system is said to be linear time variant, so it satisfies the linearity and the time variant property. Okay, let us see some examples. So determine if the system described by these equations are linear time variant or linear time invariant system. The first one is 5x1 x of n, then 3x of n plus 5, then n into x of n. Okay. So that is the y of n equal to 5 into x of n. Okay. So first we check the linearity property. So this is the if the input sequence are x1 of n and x2 of n, this is the individual responses. So you can see y of n equal to transformation of x1 of n. So in place of x of n, we are replacing with x1 of n. So it will be 5x1 of n. Okay. Similarly, y2 of n equal to transformation of x2 of n. So in place of x of n, we are replacing x2 of n. So it will be 5 x2 of n. Okay, this is the individual responses. Okay. Similarly, the output of the system to the linear combination of x1 and x2. So transformation of a1 x1 n plus a2 x2 of n. Okay. So now we are replacing x1 with this whole term a1 x1 of n and a2 x2 of n. So it will be 5 into a1 x1 of n plus a2 x2 of n. Okay. So we are replacing x of n with this whole a1 x1 of n plus a2 x2 of n. So now it will be 5a1 x1 plus 5a2 x2 of n. Okay, this is our equation 1. Okay, so the linear combination of two outputs, that is a1 into y1 of n and a2 into y2 of n. So it is y1 of n, this one is 5x1 of n. So 5x1 n. Similarly, y2 of n equal to 5x2 of n. Okay, so you can see this the both equation 1 and 2 are same. Okay, so that is why the system is linear system. The superposition theorem is applied, satisfied, that is why it is known as a linear system. Okay. So second, we will check the whether it is time invariant or time variant. Okay. Let us see that. So time invariant check. So 5 into x of n. So in case of in time invariant check, first we will check y of n comma k. So what is y of n comma k? It is the input sequence delayed by k samples and applied to the output. This y of n comma k. So in place of only the input is sample is delayed by k samples. So x of n will be delayed by k samples. So it will be x of n minus k. So that is our 5 of x of n minus k. Okay. So here the input is delayed by k samples. Second one is here the output is delayed by k units. Okay. So that will be y of n minus k. It is will be 5 x of n minus k. So in this case, all n's will be replaced by n minus k. Okay. So there is only one n there. So it will be x of n minus k. So you can see both y of n comma k is equal to y of n minus k. So this system is the time invariant system. So here y of n comma k equal to y of n minus k. So the system is time invariant. So it is the linear as well as the time invariant system. Okay. So that is why it is known as a LTI system. Therefore, it obeys the linearity principle as well as the time invariant property. So that is why it is known as a linear time invariant system. Okay. So second one we'll see. So there is 3x of n plus 5. Okay. So first we'll check whether it is linear or not. So linearity check. So the input sequence of x1 of n and x2 of n, the corresponding outputs are, this is the individual inputs. So y of n, y1 of n is the transformation of x1 of n. So that will be in place of x of n, we are replacing with x1 of n. So that will be 3x1 plus 5. Similarly, y2 of n, so it will be the transformation of x2 of n. So we are replacing x with x2 of 5, x2 of n. Okay, so that will be 3x2n plus 5. Okay. Similarly, we have the outputs to the linear combinations of x1 of n and x2 of n, that is y3 of n. So in this case, we are replacing x of n. In this term, we are replacing a1 n x1 and a2 x2 n. Okay, so that will be 3 into a1 x1 x1 n plus 3 into a2 x1 plus 5. Okay, so in place of x of n, we are replacing a1 x1 of n plus a2 x2 of n. So this is the weighted sum of the responses of the weighted sum of the inputs. So it will be this one. Okay. Similarly, if we if we calculate a1 y of n plus a2 y2 of n, so that will be this 2 will be added. Okay. So this will be 5 and 5. That will be 10. Okay. You can see over here. So this linear combination of two outputs, that is be a1 y of n, then a2 y2 of n, that will be plus 5 and plus 5, that will be plus 10. Okay. So in this case, the equation 1 and equation 2 are not identical. Okay. So that is why it is not linear system. Okay. So next we check for time invariance check. So y of n equal to 3x1 plus 5. So first we delay the input by k samples and apply to the system. So this it will be 3 x n minus k, okay, plus 5. This is y of n comma k. Then the output will be delayed by the k units. So that will be also y of n comma minus k equal to 3 of x n minus k plus 5. So in this case, you can see y of n comma k is equal to y of n minus k. Okay. So that is why the system is time invariant system. So but it is not linear. Okay. So the system is neither linear, neither LTV or nor LTI. Okay, this is LTI. Okay, so this system is neither linear time invariant or LTV. Okay, because it is not linear. Okay, so that is why it is not satisfying the linearity principle. Okay, so it is neither LTI nor LTV systems. Okay, but it is time invariant system. Okay. So let us check our third case, that is n into x of n. Okay. So here first we check the linearity. So then x1 of n and x2 of n we apply to the systems. Okay. It is the individual inputs. So y of n in place of x of n we are replacing x1 of n. So it will be n into x1 of n. Similarly y2 of n it will be n into x2 of n. Okay. So then we go for the linear combinations of the x1 and x2, that is y3 of n. So transformation of a1 x1 n plus a2 x2 n. So in place of the question is of n into x of n. So in place of x of n, we are replacing a1 x1 plus a2 x2. That will be a1 into n x1 of n plus a2 into n x2 of n. Okay. So the linear combination of two outputs, that will be a1 y1 of n plus a2 y2 of n. So y1 of n equal to n into x1 of n. So only y2 of n equal to n into x2 of n. So you can see these two equations are same. Okay. So this system is the actually linear system because the superposition theorem is satisfied and also the equations are identical. Okay. So similarly, we can check for time invariant check. Okay. So y of n equal to n into x of n. So first we delay the input sample by k. So it will be x of n minus k. So only we replace this input sample will be delayed. So x wherever there is a n in the input sample, then will be delayed by k sample. Okay. So it will be n into x of n minus k. Okay. So what is our y of n minus k? So all the n wherever there is n, it will be replaced by n minus k. So that is why it is n minus k into x of n minus k. We can see this both are not equal. Y of n comma k is not equal to y of n minus k. Okay. So that is why the system is time variant. Okay. So this system is the linear time variant system. Okay. So that is how you calculate whether the system is linear time variant system or linear time invariant system. Okay. So thank you for watching this video. So if you have any doubt, please free to ask me in the comment section. Thank you all. So have a nice day.